what is the order of this differential equation? Suppose we want to write a linear differential equation in terms of y, and we are going to solve it with the help of linear differential equation concept. Dear students, welcome to Allen Overseas. Let's continue with our special series. This series will cover 45 important topics in 45 days, and it is going to be really helpful and important for the JEE Mains aspirants. Let's look how the topics in this series are divided among physics, chemistry and mathematics. And I am going to take mathematics for you all. So let's start. Today we are going to discuss about linear differential equations, which comes from the topic of differential equation. To understand linear differential equation, let's first understand what is a differential equation. So any equation which is in the form x, y, dy by dx, d2y by dx2 equal to 0, or let's suppose if I write an equation dy by dx plus y cube is equal to 0. This is also a differential equation. So any equation of this form which is equated to 0 will be called as a differential equation. Now in differential equation there are two important terms, order and degree. So let's understand before moving ahead what is order and what is degree. As written over here, order of a differential equation is the order of the highest differential coefficient occurring in it. Now suppose if I am writing a differential equation which is dy by dx plus d2y by dx2 plus y cube equals 0. Now this is a differential equation. So what is the order of this differential equation? The highest differential coefficient and its order, right? So this is the highest differential coefficient and its order is 2. The order of this differential equation will be equal to 2. Now degree of a differential equation is defined as the degree of the highest order derivative occurring in it. So basically for degree you should also have order, right? Now degree for a differential equation can only be defined when the differential equation can be expressed in polynomials, right? If the differential equation cannot be written as a polynomial in derivatives, then degree is not defined. So basically we understand over here that degree of a differential equation is only defined when the differential equation can be written as polynomial of derivatives, polynomial in derivatives, all the terms of it. Then only we can define the degree. For example, if I have a differential equation which is like this, d2y by dx2 plus sine of dy by dx equals 0. Let's say this is my differential equation. Now I know order over here will be 2, but degree is not defined over here because for all the terms should be expressed in polynomials, in polynomial and derivatives. But here dy by dx is coming as the angle inside the sine. So here we cannot define the degree of this differential equation. Now if I have d3y by dx3 plus d2y by dx2 plus dy by dx plus y, let's say equals 0. Let's say this is my differential equation this time. So what is degree? Degree of the highest order derivative. Highest order derivative is this. And what is the degree? Degree over here is 1. What is the degree of highest order derivative? The order is 3. Highest derivative coefficient is 3. And degree is the degree of this particular term. So here the order, we can say order is 3 and degree is 1. What is the degree? We will say degree will be 1. Now we can understand that what is a linear differential equation. A differential equation is said to be linear if the dependent variable and its differential coefficients occur in first degree only. That means the degree is 1 for the dependent variable and differential coefficients. That means that it is a linear differential equation. And when will it happen? When the differential coefficients are not multiplied together, then only the the degree will increase, right? Or order will increase. Then only the degree will increase. So they are not multiplied together. That means a differential equation is said to be linear if dependent variable and differential coefficient occur in first degree only, right? For example, an nth order linear differential equation, order doesn't matter, but degree matters. Degree should be in first order, right? So dny upon dxn plus a1x into dn minus 1 upon dxn minus 1. This is the general format of a linear differential equation. You can see the degree is 1, right? dny upon dxn is the highest order derivative and its degree is 1. So first order degree, that means this is a linear differential equation. Here also you can see that this is a linear differential equation and all the coefficients of differential equation are a0, a1, an, just like we represent a polynomial expression or polynomial equation, right? Now, we can write the first order linear differential equation in two ways. Either we can write in y or we can write in x. Suppose we want to write a linear differential equation in terms of y, then it will be dy by dx plus p of y is equal to q. But over here, dy by dx plus p, this p is the polynomial in x, that means the function of x. So we can write p of x into y is equal to q of x, right? This p and q are the functions of x. So this is a linear differential equation in y. If you want to write in x, then it will be dx by dy plus, let's say r of y it will be, right, is equal to s of y. Here r and s, and it will be multiplied with x. R of y into x is equal to s of y. Here r and s are functions of y now, right? So we can write a linear differential equation in x or in y as we wish. What is the general solution? If we have an equation, we should also know what will be the general solution of a linear differential equation. Let's say our linear differential equation is in y dy by dx plus p of x into y is equal to q of x. Okay. To find the solution, what we do in this linear differential equation, what we do is we multiply both the sides with e to the power of integral of p with respect to x, right? P dx, integral of p dx, e to the power of integral of p dx. So we'll get e to the power of p dx multiplied with this on the left hand side is equal to q into e to the power of p dx. And when we solve this, when we summarize this, we'll get y into e to the power of integral of p dx is equal to integral of q e to the power of integral of p dx plus c. This is going to be the general solution. Let's say we have a linear differential equation dy by dx plus 2y is equal to 2e to the power x. This is our linear differential equation. Now we want to write the general solution of this equation. So there is something called integrating factor, right? Which we multiplied both the sides with e to the power of integral of p dx. That's the integrating factor. And integrating factor is going to be e to the power of integral of p of x dx, right? What is p of x over here? 2 is p of x, right? And this entire thing is q of x, right? 2 will be p of x and this entire thing will be q of x. So p of x dx will be my integrating factor. Now this can be written as e to the power of integral of, what is p of x? P of x is 2. Now integral of 2 into 2 dx, that's it. Not 2 into 2 dx. Now, and this is going to be equal to e to the power of 2x. So my integrating factor comes out to be e to the power 2x. And when I want to write the solution, if you see over here, in the solution y into e to the power of p dx we have done, we can take this on the right side also. So you can write the solution like this: 1 by integrating factor, which will be e to the power 2x. I'll write the formula first. 1 by integrating factor multiplied with integral of integrating factor multiplied with q of x dx plus c. This is going to be your general solution. That's it. So we can write over here very easily: y is equal to 1 by e to the power 2x, which is our integrating factor, multiplied with integral of integrating factor, that means e to the power 2x again, into q of x. Q of x is 2 e to the power x. into 2 e to the power x dx plus c. Correct? And now if we simplify this, we know this 2 will come outside, right? E to the power 2x plus x will become e to the power 3x, and integral of e to the power 3x will be e to the power 3x by 3. So basically here we are going to have y equals 2 by 3 e to the power of x plus c into e to the power of minus 2x. Right? This c into e to the power of minus 2x we will finally get. Right? This is going to be our general solution. Now let's understand more with the help of an example or a question which came in JEE Mains 2014, and we are going to solve it with the help of linear differential equation concepts we just learned. Let the population of rabbits surviving at a time t be governed by a differential equation d p of t dt is equal to half p of t minus 200. This is the differential equation which governs the population of rabbits. Now, if p of 0 is equal to 100, that means at time t is equal to 0, the population is 100. Then p of t equals what? Basically, we have to find the general solution of this differential equation. P of t we need to find. Now, first thing which I can do is, I can take p of t equal to y, so that I can write it as a differential equation. If I am taking p of t equal to y, then this equation becomes dp of t, that means dy by dt, minus half into p of t, means again y, minus half y, is equal to minus 200. I can write this much. dy by dt minus half y, p of t is taken as y, is equal to minus 200. This I can simply write, and from here only, now I just need to find the general solution. Now after getting the differential equation, now what I have to do is write the general solution. For that I have to find the integrating factor, and integrating factor is e to the power integral of p of x dx. But here we have t, instead of x we have t, so we'll write p of t dt. Correct? And this is going to be equal to p of t is minus half, so the integrating factor is going to become e to the power of minus t by 2. Right? P of t is minus half. Minus half is p of t. Right? So integral of minus half with respect to dt will become e to the power minus t by 2 will be our integrating factor. Now we have got the integrating factor, we'll write the general solution. General solution is y is equal to 1 by integrating factor, that means e to the power minus t by 2, multiplied with integral of integrating factor, that means e to the power minus t by 2, into q of x, which is minus 200 dt plus c. Now after this, I am going to shift y e to the power minus t by 2. This e to the power minus 2 by 2 is shifted on the left side, and this is going to be equal to the integration of e to the power minus t by 2 into minus 200. So it is going to give me 400, because we'll get minus 2, and then minus 2 multiplied with minus 200 will give us positive 400. Positive 400 e to the power minus t by 2 plus c. Right? The integration will be minus 2 e to the power minus t by 2. Now, this is my general solution. This is what I am getting as a general solution. And one more thing I know, that at p of 0 means at time t is equal to 0, the population was 100. The y was 100 at t is equal to 0. So I am going to put y as 100 and t as 0. So e to the power minus t by 2 will become 1, and here we will have 400 plus c. So from here I am getting that my c is equal to minus 300. Correct? From here I am getting my c is equal to minus 300. And if my c is equal to minus 300, I am going to use it over here, because I found the value of constant now. Now I'll divide this entire equation with e to the power minus t by 2. So I'll have y is equal to 400 plus, or minus actually, minus 300 e to the power t by 2. When we'll divide c by e to the power minus t by 2, so finally we'll get e to the power t by 2. And this is going to be our p of t. Right? We can also write it as p of t. 400 minus 300 e to the power t by 2. And where is this option? This is option 1 itself. Simply solve. So that's all from my side on this topic. If you have any more queries or suggestions, please feel free to reach out to us in the comment box, and don't forget to watch the complete playlist. Thank you so much. Stay tuned.